Okay guys, we are going to go ahead and get some of the vocabulary for 2.1 out of the way. And we're just going to fill out the first page of this packet today. We'll fill out the rest tomorrow in class. But I want to start by talking about the number sets. So you might have heard things before about real numbers and integer numbers and rational numbers, but we're actually going to define those today and talk about those in some detail. The first one that I want to start out with is the set of numbers called the natural numbers. Okay. Now there is a symbol that stands for the set of natural numbers, and it's a big capital N, but the one side of the N kind of has like a double bar right there. Sometimes in a textbook you might see that as like a big bolded capital N. Now, the really important part is, what are the natural numbers? Well, sometimes people call them the counting numbers, and they basically start at the number 1, go to 2, 3, on and on and on forever. And just a little note here, these are some squiggly brackets, and they literally mean, when you see those in math class, those squiggly brackets mean the set of. So what we're saying here is that the natural numbers, they are the set of numbers from 1, 2, 3, so on and so forth. The next set of numbers we would call the whole numbers. And their symbol is a big capital W with kind of like a double bar on the one side. And the only difference between the natural and the whole numbers is that whole numbers actually include 0, but then everything else is just the same as natural numbers. Then we get to integers, and you've probably heard that word before. The symbol associated with integers is kind of weird. You would think it'd be an I, but it's not. It's actually a Z, and there's like a double bar on the diagonal part of the Z. And the thing with integers, sometimes you hear people say that's just the negative and positive whole numbers. So here, integers is when we get to negatives. So it's negative and positive whole numbers. The next one would be the rational numbers. And unfortunately, they don't have a symbol. There is no symbol for rational numbers, so let's just X that out. Let's think about that word rational. You know, if somebody behaves rationally, they behave in a way that makes sense. Well, that kind of is true with rational numbers too. They behave in ways that make sense, and what I mean by that is their decimals either end or the decimals repeat. Another way of thinking about that is a rational number can be written as a fraction. It's not always written as a fraction, it can be. So the way we describe that is that it is the set of numbers A divided by B, where A and B are integers. So if you think about that, that would create a nice little fraction. So you might want to make a note. Rational numbers are numbers that can be written as fractions. Not that they're always written as fractions, they could be whole numbers, but you would be able to put that whole number over 1 and have it be a fraction. All right, the next set of numbers are the irrational numbers. And the best way to describe them, and this is going to be weird over here, I'm just going to write the set of numbers, numbers whose decimals don't end or repeat. Basically, if your decimals end or repeat, you're in a rational number, but if your decimals don't end or don't repeat, you're irrational. So that would be like things like pi. That's usually what people are most familiar with. Pi is an irrational number. If you think about it, if you were to say a person behaved irrationally, their behavior wouldn't make sense. So if a number is behaving irrationally, its behavior doesn't make sense. Its decimals are all over the place. And also that doesn't have a symbol associated with it. Our very last set of numbers, those are the real numbers. People are very familiar with those. Basically, this is pretty much any number that you can think of. We use a big capital R with that double R on the side. That stands for the set of real numbers. And over here, we just want to say it's basically all the rational numbers plus all the irrational numbers. It's basically everything. So let's practice classifying numbers. I think if you're a little confused so far, this will make a little more sense. If you look down here on number 1, I want you to take the number negative 2.77, and we want to classify it in as many ways as possible. And I always start at real. Basically, any number that you're going to see right now is real. So this is definitely a real number. So if I kind of look at my chart here, if I go to irrational, well, this decimal ends. So it's not irrational, but I could take this and make it a fraction if I wanted to. It'd be an ugly fraction, but I could do it. So that means that it is also rational. Now it's not an integer because it has that decimal, so we really don't progress further up the chart at all. All right, number 2, 178,000. That's definitely a real number. And it's also rational. The reason it's rational is I could write that number over 1 and we'd be writing it as a fraction. It is also an integer because it doesn't have that decimal. It is also a whole number, and it is also a natural number. Okay. All right. For the next one down here, 12.02002, I'm sorry, 00020002, you can see that that decimal is repeating. It's definitely a real number. And it's not irrational, it's definitely rational. That would be it. The number 56. It's definitely a real number. It is definitely rational. It's behaving nicely. It's definitely an integer. It's a whole number. It's also a natural number. And then the last one, pi. So you guys know about pi. You know that its decimal doesn't end and it doesn't repeat. So because of that, it's real, but it is also irrational. And that would be it. Okay, so hopefully that got you a nice little introduction to the different sets of numbers. We're going to talk about those some more tomorrow, but this should give you a general idea.